This is a distance equals rate times time problem. And again, the d equals RT comes in three flavors. This is just one of them. Another one would be if you solve for t, so you get time by itself. So time is equal to distance over rate. Or you could solve for the rate, and you get rate is equal to distance over time. Now time is usually measured in hours, distance is usually measured in miles for our sakes, and rate is usually miles per hour. But of course these can change. Rate could be feet per second, distance could be feet, and then time would be in seconds. Alright, so here we have Sarah spends 1 hour training for an upcoming race. She runs full speed at 7 miles per hour for the race distance, some distance going out, and then she walks back to her starting point at 3 miles per hour. And then it asks for how long does she walk and how long does she run. So the commonality for this problem is that her distance going out and coming back is exactly the same. We don't know what it is, but the distance is the same. So I might as well just write that down. Distance, the same. Oops. So when we set up our 2d equals RT portions of the problem, that d will be exactly the same. Alright, so I'm going to set this one up a little differently. Distance 1 is equal to R1 T1. Let's call this the run. And then we'll have distance 2 equals R sub 2 T sub 2. And let's call this one the walk. Alright, so what do we know? Well, one thing we know is these two values are exactly the same, so I could just call them D. Be done with it. We know what R1 and R2 are. R1 for the race running wise is 7 miles per hour going out, and R2 is the walking back at 3 miles per hour. So let's see here. D is exactly the same for both of these, so I'm just going to call it D, equals R1, which is 7. And now the time. This is one we're going to have to be a little bit more cautious with. There is a relationship for time. She spent an hour training. Now that includes the running and the walking. So the sum of T1 and T2 has to add up to 1 hour. So if we just consider time to be the slower distance, or x, we've been using x, so let x equal slower time, or shorter time, which will happen when she's running, so also running time. We'll get here that she ran for X hours. Okay, well if she ran for X hours here, and the total of T1 and T2 is 1, then the sum of X and this number down here has to be, well, 1. Alright, let's set up D2. The distance is exactly the same, so we're just going to call that D. R2 is 3 miles per hour. And when we get to T2, we've already used up X hours. And it's only 1 hour to begin with. So we have to take whatever time we've used up and take it away from 1 hour. So here we're going to get 1 minus X. And you can check yourself that if you add these two together, X plus 1 minus X, that your sum is just going to be the one we're looking for. So here's our two formulas, and what's true about them is they're both equal to D. So this actually becomes a nice easy equation. 7x is equal to 3 times 1 minus x. The distance running is equal to the distance walking. Alright, and then just solve. So this becomes 7x equals 3 minus 3x. In this case we're going to add the 3x across to get the x's on the same side. So we'll come up with 10x is equal to 3, and then divide both sides by 10. Now remember, x in this case represents the time of the run speed, so or the time running. So this is 3/10. The measurement, it has to be in hours because we're talking about miles per hour up here. So this would be 3/10 of an hour. Now, if you're interested in exactly how long that is, 3/10 of an hour, you can change it into minutes by multiplying by 60. So let's see, 10 goes into 66 times. 6 times 3 is 18 minutes. So she spent 18 minutes running. So how long did she spend walking? So this is 18 minutes running. And the walking is 1 minus the 18 minutes, or 3/10 of an hour, which is, let's see, that would be 10 over 10, 7/10. And again, we can multiply this by 60, and we find out that it was 42 minutes walking. Kind of scrunching it up there in that corner. So she spent 18 minutes running and then 42 minutes walking back to the beginning of the exercise.